Hey, what's up, everybody? We're going to be doing that exploratory data analysis that I promised you. Hope you are all doing well in this quarantine, or if you're watching from the future, hope you're doing well then as well. But yeah, let's see what we got going on here. I picked a data set for us. The data set is going to be this Citibike system data. So the idea here is to have you guys watch me do an exploratory data analysis on a data set I'm not familiar with to just see how the process goes, see what kinds of things we look at, what we're interested in, so that you can apply some of the same techniques to whatever data set you're choosing to do your project on. So if you're not familiar with Citibike, I feel like I'm assuming most of you at least have a rough idea of what it is, but it's a bike share program where there's like a bunch of docks around the city, and you can take a bike out of a dock, ride it around, dock it somewhere else. It's got my recommendation. Love Citibike. Was excited to see that they had some free data available. So I clicked here, got a bunch of these zip files. You can see I'm in a Colab notebook here. So what I've done so far is I'll share this link with you guys after I post the video, but I just downloaded all these zip files. Probably a more clever way to do this, but name of the game here is going to be going fast, so I just did it this easy way. Unzipped the zip files, and then I have read the CSVs into 12 different data frames. So I got from this website, I got the zip files corresponding just to 2019. So we've got January through December 2019, and those are the 12 data frames that we've read in here, and that is all I have done so far. We're about to look into them. So when we look into them, Citibike is telling us we'll have a bunch of things. We'll have the trip duration in seconds. We'll have start time and stop time, station names, station IDs, station latitude and longitude, the bike ID for the individual bike. So user type says if you're getting a Citibike, you can get an annual membership, or you can do like a 24-hour pass. So it's telling us what kind of customer it was. Gender of the customer, notice we have 3 different options here. 0 is unknown, and year of birth. And then they give a little note here that trips that are taken by staff have been removed, which is good, and any trips below 60 seconds. So that's could be like someone gets a bike and realizes it's broken or something like that. So trips below 60 seconds have also been removed. So let's just look at the first one here and see what we got. So yeah, everything looks like it imported correctly, looks exactly like what they were telling us it was going to be. Looking good. So the first thing I want to do is actually get all of these into one data frame, so I don't have to work off of these 12 data frames here. So to do that, I actually need to look up the command. It's going to be, my screen share is in the way. There we go. So if we want to append rows to a data frame, looks like it's just this data frame dot append and just the other data. Sweet, seems easy. So they will need the same columns, so we can just check they've got the same columns here. Looks like they do. So let's just try df1 dot append df2. Is it that easy? Looks like it was that easy. So we had 38,241. And if we do length plus length, 38,241, sweet. So it seems like that's working without a problem. So we'll call our data frame df1.append df2. And then let's see, probably a better way to do this, but we're just going to make a whole string of them here. Get to see all of the fun workarounds that I come up with. So we've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh no. Data frame object has no attribute df1. I don't know what this error is. Oh, I see. That was silly. Very good. All right, so let's check this guy out. That seems about right. All right, so next thing I want to do is check for some missing values. So let's just check first some of these individual ones. Cool, so it looks like this data set's pretty clean. These numbers are all the same. Yeah, it looks like we should have no missing values in our big data set, and that's what we got. So that's good. That takes care of a lot of the data cleaning that we might have had to do. Next thing I want to do, I think, is just start looking at some of these individual columns to see what's up. So take a look at trip duration. Start time and stop time are objects. I don't know if they are, I doubt that they're datetime objects. So if we do type start time dot values and just get the first values, yeah, so the date time and start time are strings. So we could just do, so I'm thinking ahead, we're probably going to want to do some things like make some graphs of like the time of day that people are riding bikes, or the day of the week that people are riding bikes, or the month. So we could just get that out of the string, or we could convert these to datetime objects to make that a little bit easier. So let me make a little list of the things we want to do. So we want to look at the distribution of trip duration. We want to convert start time and stop time to datetime objects, maybe. I hate datetime objects, so it might be easier to just work off the strings. We'll see what happens. Start station ID, I'm not that interested in. Start station name, I'm not that interested in either. Latitude and longitude, okay, so we could do like some, what is it even called, like geocoding or something like that, whatever it's called, where you look up the latitude and longitude. So we don't have any like neighborhood or borough or anything like that, which could be kind of helpful to be like, oh, which rides are between Manhattan and the Bronx or something like, or I guess there's no Citibike in the Bronx, but you know what I mean. I don't know if, we'll see how long, we'll see how fast I'm able to go. I don't know if I'll get to that today. So end station ID and name, latitude and longitude. Bike ID I'm not that interested in. User type, we can just look at distribution of user type really quick. And in birth year, we can look at that. So these are the things I'm hoping to accomplish on this next 30 minutes or so. Let's start with trip duration. So we just make a histogram really quick. Okay, cool. This is exactly why we do exploratory data analysis, is we made this histogram of the trip duration, and we can already see that something kind of funny is happening here. So we've got, so first of all, this is in seconds. So maybe before I do anything else, I'll just make a minutes column, because that'll be a little bit easier to interpret. This will work. Oh yeah, pandas always yells at you when you make a new variable by using the dot notation instead of this bracket notation. So that did not in fact work. So sorry pandas, please forgive me. Oops. There we go. Did that do what I wanted it to do? Looks like it did. So these are now trips and minutes. So if we do the histogram again, okay, so same thing. So we've got some values up here that are like 10,000, 40,000 minutes. That seems like a lot. So if we're going from minutes to hours, we divide by 60 again. Oh yeah, these are like, so even 10,000 is like a 6-day, 7-day Citibike ride, is that right? Weird. And 40,000 is like a whole month long. So this seems to be, there seems to be some trips in here where someone like takes a dock out. It's honestly, it's probably that there's like an error when they try to put it back in and it doesn't actually get put back in, and then it might be like a week later or whatever that someone actually comes around and puts it back in for real. Or maybe they're like stealing the city bikes or something. You get a fine if you have it for longer than 45 minutes. So don't know what's happening here, but it seems like, let's take a look at, so I'm going to limit the data frame to trip durations that are greater than, I guess, trip minutes that are greater than, let's do like 5,000. Well, let's do greater than. So I said 45 minutes was the when you get fined. Let's just do greater than like 100. So it's 2,000 out of the like 400,000 that we had, which isn't that much. And some of these values are more reasonable, like 217, that could have just been someone that took it out for a while and didn't care about the fine. So let's do a little bit, let's see what these like 10,000 ones are. Okay, so it's only a handful, like 20 or so trips here. So I'll leave them in for now, but this is the sort of thing where once I start doing analysis, like if I was trying to actually predict the trip duration or something like that, I would just cut these guys out of the data set so they're not skewing things too much. But that was a perfect example right off the bat of why we do this sort of thing, because I might not have thought to look at these weird values of trip minutes if I hadn't seen this histogram with this odd shape. So let's look at the distribution of, let me get back what I just did. So we want to do less than, let's look at the distribution of the ones that are less than, what's a good value? Let's just do like 500 minutes or something. That's not what to do. So we do a histogram to look at the distribution. Oh, dang it. So this is doing a histogram on the whole data frame. So I just want to see, so we limit the data frame to only trips less than 500, and then we get the trip minutes attribute, then we call the histogram. Okay, so it still is so skewed, so let's limit it to ones less than 100. Oops. All right, so it's looking like a whole bunch of rides are less than, like the vast majority of the rides are even less than 10 minutes, which is a little bit surprising to me. I kind of expected it to have a hump more around like 20 or 30. That's usually how often I'm writing it for. I guess I write it for 10 minutes sometimes. But it looks like there's a lot of rides that are, clustered on the low end here. So let's look into that. So they said they dropped rides that were less than 60 seconds, but I'm wondering if we've got a bunch of rides here that are clustering around like 1 or 2 minutes. So let's do trip minutes less than 2. Let's just see how many there are first. Okay, so only 14,000 is kind of a lot, but again, our whole data set is 400,000. Let's see. So at least some of these are, looks like most of these are different locations. So one thing I'd be interested in looking at is where these IDs match. That could be another sort of, weird thing happening in our data here. There's not a whole lot of reasons you would take a bike out of the station and then put it back in the same station unless it's like broken or um, some other issue like that. I guess you could like ride to the store and just park it outside the store and ride back or something like that. I don't know. But the point being that they dropped ones that were less than 60 seconds, but we might want to drop ones that are less than like 120 or 180 seconds or something like that. But again, I'll leave it for now just to have the whole data set. That's something I would do once I start feeding it into a machine learning algorithm. But yeah, perfect. So we looked into what was happening in our trip minutes here. We found some outliers both on the high and the low end. So now we have a better understanding of what we can expect once we start trying to predict trip duration if that's something we're interested in, or trying to do more visualizations on trip duration. And so that was kind of the essence of exploratory data analysis right there, but let's keep going. I'll come back to converting these. These will be pretty quick here. Let's go ahead and look at the distribution of the gender. So df.gender, since this is a, what's it even called? The opposite of a continuous variable, like a nominal or ordinal or whatever. We can use value counts as an easy way to get a feel here. So this is interesting. So 0 was the unknown. So 26,000 unknown. I'm sure those are just people that opted to not put their gender on when they signed up for the app or whatever. Or they could just be, it might be that we only have the gender data for the actual members and not for people that just pay with a credit card at the kiosk. So that makes sense. What was 1 and what was 2? So 1 is male, 2 is female. So a lot more males here. Not what I would have guessed. I guess would have guessed it would have been more even, but there you go. Learned something interesting. I don't think there's much I want to do here. Mostly if there had been like a value other than 0, 1, or 2, that would have obviously been a red flag. But yeah, that checks out. So let's look at birth year. What's the easiest way to look at birth year? What is birth year even called? Is there a space? Yes. I guess we can just do another histogram. Okay, so this is another perfect example where it's the same thing as up here, where we've got some values. These numbers wouldn't be here if there weren't values down here. So it looks like we have some birth years. It's like we've got some elderly people riding Citibike. So let's, which could be cool, not to say that elderly people can't ride Citibike, but let's look at birth years less than like, what, 1920 or something. Yeah, so I'm not believing that there's a bunch of people born in 1888 that are out here in New York, right? Taking some joy rides on our city bikes. So this is kind of funny. So there's 200. So again, it's not very many. These, if we were trying to do something with birth year, these could just drop these. I'm guessing it's something like, when you're like a kid and you're like trying to buy a video game on Steam or something, and you put like 1500 as your birth year because you think it's funny. Or this is 1888. Since there's so many that are 1888, it's probably like that's the one that's like at the top of the list when you're like scrolling to select your years. So people just like do that one or something. So yeah, another good thing to be aware of. Not a big deal. We could just drop it if we need to, or we could, instead of dropping it, we could do something like if it's less than like 1920, 1930, we could fill it in with the mean value or something like that. But again, only 200 rows, so not a big issue. Something to be aware of for sure. So that was gender, birth year. User type will be another easy one. Let's just look at user type. I lost my columns. User type, oh, one word. This is another one where we can just use value counts. So mostly subscribers, a couple customers, checks out for me. All right, so now let's get into these date time. Let's get into these date times, because that'll be the interesting thing to kind of visualize and stuff anyways, is how the amount of rides changes by time. So let's try converting this to a date time. I may regret that. Cool. Well, I'll edit this part out of the video. We'll do it by strings. Makes me sad. All right, so let's just get, so the year will always be 2019. Let's just extract the month from this. So yeah, it should just be one, so 0, 1, 2, 3, 4. So it should just be 5 and 6. I'll leave that there for now. So month, I should say start month. I think we can just do it like this. So what did I say, 5 to 6? But now we have this timestamp. Oh no. Oh god. All right, so I'm just reloading. We'll run these guys. All right. Comment these guys out. See if that worked. Cool. Seems good. So let's look at this. This will be another good way to check if it worked. Cool. So this is exactly what we would expect. So these cold months are much lower than these summer months. So this is a good opportunity to make a little bar chart. Got Carlos's handy visualization notebook over here. Going to go ahead and reuse some of his code. So we need a names list. So the names list can just be this index here, I think. See if that works. Cool. That should be good. Force it into a list maybe. Cool. Does index.values work? I'm just curious now. Sweet. All right. So those are our values, and then, sorry, those are our names, and then we need our values. So we can get that. This is just the value counts here. What was it called? Values list. I think this will just be value counts.values, but let's double check. No, I didn't get my parentheses. Cool. So that's our names list, that's our values list. Are they in the same? Do we need to like sort them? Sorry. Values list not defined. Can I not run that again? So, okay, so they're both in the order they're listed here. So that's cool. Maybe I want, yeah, let's just go ahead and make the visualization. I think the visualization is not going to be in a great order, but we'll fix that in a second. So what do we need to change here? Anything? I guess just our, so this is total rides. This is month. This is rides per month. Cool. So I don't want it to be just in this weird stair step here. It's because this value counts is sorted by, you know, the actual value here. So I want to sort the value counts by the index. So I'm sure there's an option to do that. Sort by frequencies. Maybe if I just set that to false, see what happens. What was it? Sort equals false. No. Called dot sort index on it. All right. Try it up here first. Sweet. Great, beautiful. Wow, look at this. So we got the winter time, we've got a peak in the summertime. It peaks in September. That's kind of cool. Huge drop off between September and October. But great, look at that. Exploratory data analysis, learning about seasonal changes in city bike rides. Maybe real quick, let's do the same bar chart, but for hours, and then we'll call it a day. So hours is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Space is 11. So 12 and 13, but I didn't start counting by 0, so 11 and 12. Let's see. So same thing up here. I think we're going to want to do 11 to 13. Let's see what happens. Oh, no, I just did start. Start hour. That seems right. These values all look normal, right? And like midnight is much less than these other ones. Cool. So we're going to do the same thing we did up here, but we're looking at start hour instead of start month. And we'll just redo this guy. Rides per hour. Cool. This is a great one. So at nighttime, really, really, really low. And then 2 spikes, pretty clearly the 2 spikes when people are commuting. Yeah, 18 is 6 o'clock, 8 o'clock in the morning. Yep, that looks cool. So yeah, that was our exploratory data analysis. A lot more you could do with this data set. Like I said, you could start looking at geography. You could use these, where'd that little list go? You could use these latitude and longitudes to plot some things on a map. You could do even more with time, like day of the week and things like that. But hopefully that gives you an idea of the kinds of things that you could be doing on your data set. You know, just getting in there, getting familiar with the weird little quirks, first of all. So the fact that we've got some weird birth years, the fact that we've got a handful of rides that have or, you know, where people took the bike out for a month or whatever. So it's good to be aware of those things. And then just kind of, you know, doing some gut checks with some visualizations to see what kind of patterns are there to kind of give you some avenues to explore further. So we'll see. I think maybe I'll make another video where I do some machine learning. We could like try to predict trip duration, though that seems hard because it would be so dependent on the station you're starting from and the station you're going to. But we could also try to predict like demand at a specific station. Like, are there stations? This is for all the stations. Are there stations where the graph looks different than this? Oh, it would be cool to see the difference. Actually, I want to do this real quick because it'll be so cool. This should have been hour. So yeah, maybe I'll do a machine learning video. To wrap up real quick, I want to do this graph for weekdays and then this graph for weekends because I'm just curious to see how it looks. No, but then I'll have to go code the day of the week and everything. All right, that's what the date time would have been really useful for, is getting the day of the week, because that'll be a lot harder to do by strings. You'll have to like look at what the first day of the year was and whether or not it's a leap year and all that sort of stuff. So that's the reason to get the date time working. Maybe I'll look more into that date time issue and see what the problem was. But I hope that was helpful, and I will see you guys in class. Have a good one.